In today's video, we're going to look at division using the long way under standard algorithm. Before we go over the vocabulary, I want to write two examples. We're going to use 10 divided by 5 equals 2. For these examples, the dividend, which is the number that you're dividing or sharing, is going to be the 10. And we have the divisor, which is the number that we are dividing by, is going to be the 5. And then the answer to a division problem is going to be called the quotient, which is 2 in this case. Now for these examples, we do not have a remainder, which is the number remaining after dividing into equal groups. Before we actually start going over the long division, I also want to touch into some vocabulary words related to multiplication, because as we're going to explain, both the multiplication and division have a very special relationship. So for the vocabulary here, I'm also going to write an example. I'm going to have 10 times 3 equals 30. And I'm also going to write it using the same factors, just rewriting the order of the factors. So for the vocabulary related to multiplication, a factor is going to be the number that is being multiplied in a multiplication problem. In this example that we actually have two factors, the 10 and the 3. And then the product is going to be the answer to our multiplication problem. As you see, it doesn't matter if the 10 is first or the 3, we still get the same product. Like I mentioned before, the multiplication and division have a very special relationship. Both of them are the inverse. What that means is that if I have a multiplication problem such as 10 times 3 equals 30, if I do the inverse operation, will be to divide. That means that now the 30 is going to be the number that I want to divide. The 10 is going to be the divisor, or the number that I'm dividing by. And then in this case, the 3 is going to be the quotient. Now I can also write the division problem in a slightly different way. I'm still going to divide the 30, but in this case I'm going to use the 3 as a divisor, or the number I'm dividing by, and now the quotient is going to be 10. Now, without using numbers, what this basically means is that if we had a multiplication problem where we have two factors, we're going to get a product. If we were to do the inverse or divide, now this product is going to be the number that we're dividing by. One of the factors is going to be the divisor, and that missing factor is going to be our quotient. Now if we remember the vocabulary that we use for division, now the dividend, it's the number that is basically inside or under the house. The divisor is the number that is going to be outside, and then the quotient is going to be at the top, which is the answer. Now let's take a look at two examples. We're going to start with this one right here. So please take a moment, pause the video, and read the example before we even try to answer it. Now that you have read the problem, I want you to go ahead and follow the 4 steps that we practice in class using the problem solving mat. While you do that, I'm going to read it for you. It says Mitchell has 182 stamps in his collection. He wants to display the stamps on 13 pages in his scrapbook. How many stamps will be displayed on each page of his scrapbook? Now, if we can apply different strategies to solve this problem. Some of the things that we know. So let's follow the 4 steps that we use in the class. First, I want to know what I need to find out. In this case, I want to find out how many stamps Mitchell is going to place or display on each page of his scrapbook. Now, some of the information that we know, which is the second step, or that we're given, is that he has a total of 182 stamps. We also know that he wants to display it on 13 pages. Now, my strategy is to take the information that I'm given, and I'm going to use a strip diagram before I even try to divide. So if we remember from the strip diagram, we're given right here the total. So that's going to be the number at the top of the diagram. Now, what we know from the inside is that we're going to have 13 pages. So that's going to be how many sections we're going to have inside our model. That should be 13 parts. Let me double check. All right. Now we need to find out how many of those stamps are going to be on each of these 13 sections. Now to do that, we're actually going to use the long way to divide. 182 is going to be our dividend, the number that we want to divide or share. And 13 is going to be our divisor, the number that we're going to be dividing by. So that goes outside. Now we first are going to ask ourselves, how many times does the 13 fit inside the 1? We know that not even 1 time, so that means that we have a 0. Now we have 18. How many times does the 13 fit inside the 18? We know that that's going to be 1. So 13 times 1 is 13. Now we subtract. 8 minus 3, 5. 1 minus 1, 0. And we drop the 2. Now we have 52 divided by 13. We ask ourselves the same question. How many times does the 13 fit inside the 52? Now for this one, I'm going to do some guessing and checking, or some trial and error. So I'm going to look at the multiplication facts of the 13. And I'm going to start with 13 times 2. I know that 2 times 3 is 6, and 2 times 1 is 2. I'm still far from the 52, so I'm going to use 13 times 3. 3 times 3 is 9. 3 times 1 is 3. Getting closer, but not there yet. I'm going to use 13 times 4. Now 4 times 3 is 12. I'm going to carry 1. 4 times 1, 4, plus 1, 5. Now I know that the 13 can fit inside the 52 4 times. I'm going to place the 4 on top of the 2, and I multiply 13 times 4 is 52. I subtract, and I get 0. So that means that for this problem, we have a remainder of 0. For this problem, we got the total number of stamps, and we were given how many groups or how many pages he wanted to display those stamps. So that means that our answer, our quotient, is 14. That means that we're going to have 14 stamps on each of these pages. Now let's take a look at a second problem. In this case, we have the local baseball team paid $180 to attend an Astros game. Each ticket costs $15. How many players from the local team were able to attend the game? Go ahead and again follow the 4 steps that we use in the classroom. We're going to start by asking what do we need to find out, and we know that we basically have to find out how many players are going to be able to attend the game. So our answer should be the number of players. Now, what information are we given on the problem? We know that the team paid a total of $180 to attend the game. And we also know that each of those tickets that they paid for cost $15. Now again, I'm going to try and apply the strip diagram bar for this problem. We know again that the total is going to be 180, and we know that each ticket is going to cost $15. Now in this case, we do not know how many players are going to go, but I know that each of those tickets cost $15. So how many, and this is the part that is unknown right now, how many sections or how many people, because this means each of these sections or boxes that we draw actually mean the number of players. So this will be 1 player. And we don't know how many are going to be able to attend. So I'm going to proceed and divide, again using a long division. 180 is our total amount of money that they paid, so that's going to be our dividend, or the number inside the house. We also know that each ticket costs $15. That means that that's going to be our divisor, or the number that we're going to divide by. Again, we're going to ask ourselves, how many times does the 15 fit in the 1? We know that that's 0. Now, how many times does 15 fit inside the 18? We know that 1 time is 15, 2 times is 30. That's too much, so we're going to go with 1 time. So 15 times 1 is 15. We subtract. 8 minus 5 is 3. 1 minus 1 is 0. And now we drop the 0 and we get a 30. Now, how many times does a 15 fit in the 30? Again, I'm going to use the multiplication facts using 15 as a factor. I know that 15 times 1 is 15. 15 times 2. 2 times 5 is 10. Carry 1. 2 times 1 is 2 plus 1, 3. So I know that 15 can fit twice inside 30. So 15 times 2 equals 30. We subtract and we get again a remainder of 0. What this 12 represents is that 12 players are going to be able to attend the game. So that means that if we were to complete the strip diagram here, we would have, that's 1 player, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Pardon that not all the sections are the same size, but you get the idea. That means that if each player, remember that each of these boxes represent 1 player, and each one paid $15, that means that 12 of them are going to be able to attend the game.